Hey everybody, Mr. Quick here, looking today at Eureka Math / Engage New York Math, Module 1, Lesson 26, percent of a quantity. Now we're going to use some percentages or part of a percent or part of the problem to solve the whole or part of the whole or find the percentage. A lot of stuff there to unpack. Let's jump right into it. Okay, example 1 says 5 of the 25 girls on Alden Middle School soccer team are 7th grade students. Find the percentage of 7th graders on the team. Show 2 different ways of solving for the answer. One of the methods must include a diagram or picture. So we've got to answer the question, 5 out of 25, what's the percentage? And 2, we've got to show 2 different ways, including a diagram or picture. Okay, well, let's jump into this. First things first, we know we're looking for 5 students out of the 25 total. Percent means per 100, so we want to convert this into something out of 100. 25 is all of the girls on the team. 100% would be all of the girls on the team. So we know our constant, or our magic number, would be times 4, right? 25 times 4 gives us 100. 5 times 4, if you do it to the denominator, you have to do it to the numerator, give us 20. That's giving us 20% of the team are 7th grade students. That's one way to solve it, and that gives us the answer. Now let's solve it another way. We know that it is 5 out of 25 students that are 7th graders. Now if we look at this fraction as a division problem, we can actually do 5 divided by 25. 25 goes into 5 0 times. 0 times 25 is 0. We subtract, we get 5. We need to bring down a 0 here, which we can do if we add a decimal. So we can bring down that 0. Once we add the decimal, though, we have to make sure we add it in the same location in the answer. 25 goes into 50 2 times. 2 times 25 is 50. We subtract, we get 0, nothing left over. So we have 0.2, which we know, since it's after the decimal, it's at the end of the number, and at the end of the decimal, we can add zeros if we need to. 20 hundredths, 2 tenths, or 20 hundredths gives us 20%. Now I'm going to show you a visual model, since they said one of them has to be a diagram or picture model. I'm going to show you a visual way of doing this as well. Okay, I'm going to create a tape diagram here. I know this is 0 and 0, and I know over here we're going to have 100%, and 100% of the students is 25, right? That means all of the students, so 25 students. Now, I want to know where we would be with 5 students. So, if I take that 25, and I know I'm counting by 5s, so I'd have 5, 10, 15, 20, and then 25 is already on there. I know that the 100%, what percentages I'm going to put on top, would be 100 divided by 5, because we're counting by 5s. So if you do 100 divided by 5, you're going to get 20, and that's how we're counting across the top. So we'd have 0, 20%, 40%, 60%, 80%, and 100%. So now I can easily look and see, okay, well, there's 5 girls. Here's the 5. That correlates to 20%. So 20% of the girls are 7th grade students. All right, let's look at a couple more examples. This is example 2. It goes with that same word problem. Of the 25 girls on the team, on the Alden Middle School team, 25 girls on the team, 40% of them also play on a travel team. How many of the girls on the middle school team also play on the travel team? Different question here. How many of the girls? It's not asking for a percentage, not this time. It wants to know how many girls. So I know that there are 25 girls on the team. I know if I'm going to do this as a percentage that my denominator has to be 100. I know that 40% of the girls play on the team. That is 40 out of 100. So in this case, I know the percentage. It's 40 out of 100. What I don't know is how many girls would be 40%. But we can figure that out. So in this case, 25 times 4 gives me 100, but I don't know what would go here times 4 to give me 40. Now, if you know your math facts, you know 10 times 4 gives you 40, and you would know it is 10 girls who also play on the traveling team. Now, if you didn't know that, if you weren't sure quite how to get there, or if it was a more complicated number, what you could say then would be, okay, I know the percentage was 40 out of 100. I know, let's erase this, I know that that's going to give me something out of 25, because remember, 100% of the girls is 25. Instead of multiplying, now I can divide. 100 divided by what gives me 25? Well, if I do 100 divided by 25, I'm going to get 4, right? So 100 divided by 4 is 25. I also think when it's numbers like this, I can think of 100 cents in a dollar, 25 cents is in a quarter, 4 quarters gives me 25 cents. Or I should say 4 quarters gives me 100 cents. So up top, 40, got to do the same thing. 40 divided by 4, it's going to give me 10, and that's the number I didn't know. 10 girls play on both teams. We know that if it's a word problem, you've got to write words as part of your answer. All right, let's do one more quick example. All right. Oops. Okay. There are 60 animals. There are 60 animal exhibits at the local zoo. What percent of the zoo's exhibits does each animal class represent? Well, here we have the exhibits. Here's how many of them there are, and then here is the percent of the total that we have to figure out. So percent of the total would mean we're figuring out part of the whole. So for the mammals, looks like there are 30 mammal exhibits. We know there are 60 total exhibits. So we're looking at 30 out of 60. Two ways we could do that. We could do the division, figure that out, but also you can recognize, hopefully, 30 is exactly 1/2 of 60. 1/2 would give us 50%. Reptiles and amphibians, there are 15 reptiles and amphibians. That would be 15 out of 60. So if I look at 15 out of 60, I can do that a couple of different ways. One, I could actually divide 15 divided by 60. 60 does not go into 15. It goes 0 times. Subtract. Get 15. Add the decimal and a 0. Bring that 0 down. Add the decimal up top. 60 does go into 150 2 times. Gives us 120. 150 minus 120 is 30. Bring down another 0. 300. 60 goes into 300 5 times. 0.25 gives us 25%. So you can actually do the division. You could also simplify this and say, okay, 15 divided by 15 gives me 1. 60 divided by 15 gives me 4. 1/4. If I wanted to make that into 100, I'd have to multiply by 25. I'd have to multiply that by 25. That gives me 25 hundredths, 25%. The other way you could do it is you could say, well, I know for the mammals, there were 30 of them, and that was 50%. For the reptiles, there's 15, which is half of 30, so my answer should be half of 50, which is 25%. All right. Now we have fish and insects. There's 12 out of 60 total. Okay, we look at 12 out of 60. I can simplify that because I know 12 goes into 60 evenly. So my constant, or my magic number, is 12. Divide both by 12. I end up with 1/5. Now, if I wanted to get 1/5 to 100, I've got it times by 20, multiply by 20, and I end up with 20 hundredths, or 20%. Quick little note here. I knew that 12 goes into 60 evenly. If you didn't just know that, if you divided by, let's say you recognize, well, 6 goes into both of these. So 12 divided by 6 is 2. 60 divided by 6 is 10. There's my dog. Hello, London. You know, you should be able to see, hey, these are both even numbers. We could still divide that again. Divide both by 2. You'll get 1/5. So you can still do the problem. You just will have to add another step. So don't be intimidated if you didn't know right off the bat, hey, 12 and 60 can both be divided by 12. Finally, we have birds. There are 3 birds, 3 out of 60. If I look over here, 3 out of 60 can both be divided by 3. I get 1/20th. If I want to find out what the percentage is, I need to get it out of 100. That's times 5. This is also times 5. Gives me 5/100ths, or 5%. If I wrote that as decimal, it would be 0.05, right? Because remember, 0.5 is actually 50%. So I want to show you one other quick thing here. If I solved and I got 50% here, and I got 25% here, and 20% here, 50, 75, 95. If you add all 3 of those up, you have 95%. I know that all of these represent all of the exhibits, so I know that that whole thing equals 100%. Well, if these equal 95%, then this has to be 5% because that's all that's left. So you could also do it that way. Okay, that is all the time we have here. Thank you for watching. We're going to talk about this more in class and do some more examples together. I'll see you then.